Hello everyone, this is Direwolf20 and welcome to episode 83 of Direwolf20's Let's Play. I'm just wrapping up placing all the wiring and whatnot for this little system. I told you I'd be doing this off camera between last episode and this one because all it consisted of was me placing down all these IOX extenders and all these cables. But it's the exact same layout that I put on the other systems. However, I'm going to make a minor change here. After I did a little programming on my computer, I realized I wanted to change things up, so I'll be doing that on camera. But basically what I did at the end of last episode, which was put, all these things here and put all the wiring down, I just duplicated here and over here. And you might be wondering why I have the I/O extenders over here on the right rather than the left, which maybe you thought would be more intuitive. I don't know. That's what I thought. I initially wanted to put them on the left, but after looking at it, I realized I wanted them on the right, and that's because I wanted the white wire here, okay, which is going to be, the first position, to be activating this block, and the white wire over here is also activating to this block, and I want the white wire to activate on this block here. So notice that all the white wires on the top I/O extenders activate on this block, and the white wires on all the second row of I/O extenders activate on the second row of this block. Okay, so what we've got is pretty much a pattern here, in that all the white cables activate something on the far left column, right? So white cable, white cable, white cable, white cable, all the way down, okay, on all sides, will activate the far left column all the way up and down. And orange will activate the next column. Let's see. So orange will activate this column, the second column. Okay, so we want to keep that in mind as we start playing around with our computer. Now, there's a few changes I want to make, which I mentioned, but then a lot of this episode is going to be done with the RP computers. I've gotten a little better with them, not great still, but I'm getting there, and I'm getting my mind wrapped around a stack-based language, and I'll be trying to explain to you guys as best as possible how a stack-based language works and how to use these computers. I did a little bit of programming in the frame quarry, but this is definitely going to require more effort, so that's what's going to happen in this episode. Going to have a few other things to tweak, but hopefully I might be able to wrap up at least part of this segment this episode. And once I've got everything demonstrated for you guys, you'll be able to see the versatility of this little 10 by 10 screen here. Hopefully you'll approve and appreciate it. So let me change a couple changes real quick now, and I'll be back when I'm ready to do those, like I said, on camera. Alright, I'm standing flying around up here with my sonic screwdriver ready. Remember at the end of last episode, and I don't even know if there was a particular reason that I did it this way, but I made the bottom here number 10 ID, and this guy here number 11, and all the way up to, at the top, dun dun dun, 19. Well, I want to switch that up. I want to change it so that this guy is number 10, and this guy is number 11. And let me get them all changed up, and then I'll be back when I'm ready to show you why I did that. Alright, so now what we've got over here is, okay, the top guy is number 10, and then 11, and then all the way down to 18 and 19, okay? Now let's circle around to this side. You'll note that this side I started down here at number 20, okay? So I'm going to go from 20 to 29, but again I want to reverse this and have 20 at the top. So let's go with probably something like there. Alright, so I'll be back again once I've got this guy set up to do straight up and down. Alright, so now we've got 20 through 29 controlling the green lasers. And finally, I have to swap one more set of I/O expanders over here on the back controlling the red lasers. I have to go from 30 to 39. So how about I get those guys all going now? Okay. There we go. 30, 31, 32, 6 and 1 should be 33, 6 and 2, 34, 35, 36, 37. 38. And finally, 39. Woot. Alright, now that I swapped everything around, let's go play with the computer and figure out some of the crazy stuff that I've been writing here. Now this may look like a whole bunch of gobbledygook, but my goal is to try and get you guys to understand what I'm doing so that hopefully expands your knowledge of Forth and gets you to be able to do some pretty, not so like crazy complex, but pretty straightforward. So let's now get into how we can work with a stack-based language, which is what Forth is, and what it does. Alright guys, so let's try to explain stack-based languages. Alright, here's the way it works. I've set up this pretty much a tower of red power cover plates, okay, and they're stacked one on top of another, and they're all empty right now. When you are working with a stack-based language, any numbers or variables that you place on the stack go on the top of the stack, okay, and it starts to work from the top down. So let's imagine that I wanted to issue the command to activate IOX address number 10, which is that top right IOX thing, okay? The command we'd enter is as follows. I typed in 10 IOX address and then the exclamation point. And what that does is 10 is the number that's going on the stack, okay? And in a representation here visually, I'll place a little red power ribbon cable on the top of the stack. Boom, placed right there. Okay. So now we've got this number 10 sitting on the top of the stack. The next command that is entered after the space is IOX address. This is a function that uses the number 10 and executes a command on the computer to change the IO expander on the program. And the exclamation point actually executes the command. So when the IOX address command is executed, it takes that number 10 that's sitting on the top of the stack and executes it, and then it removes it from the stack. Boom, 10 is removed. Okay? Makes some good sense. So that's how a stack-based language works when there's just one variable sitting there. Okay? The variable goes on the stack, and when you execute a command on it, it pulls it off the stack. And to demonstrate that even more, what we can do is we can open the computer here and just put a number on the stack like 10. Okay, now 10 is sitting on the stack. If you want to see the top number on the stack, you just type the number, just type a dot. Note that it output the number 10, but the dot is actually a function, so it's going to pull the number 10 off the stack. If we type a dot again, now we have an empty stack. See how that works? Okay, so what we've done is we put 10 on the stack, and then we did something to it, and it got pulled off. I could also type 10, and then IOX address, and note that it executed that command no problem. And now when I do the dot, the stack is empty still. So 10, I put something on the stack, the number 10, and then IOX address, I executed on that stack. Oh, and by the way, I got a little correction on the exclamation point doesn't actually execute a command. It's the fourth implementation to write out to a memory address. So the IOX address is getting written out to that IOX address thing. And the @ symbol, by the way, is a read command. But we'll get into some more of that later. But let's talk more about stacks and how they work when we want to talk about having more than one thing on a stack. For example, what if we wanted to add 2 plus 2? Or in this case, let's say 2 plus 5, just to make it easier. We write 2, 5 plus. 2, 5 plus. Okay, and what that does is it puts the number 2 on the stack, then it moves the number 2 down a slot, puts the number 5 on the top of the stack, and then the plus sign is a function that needs two numbers to interact together. So it takes both those things off the stack and adds them together, and it puts the combined number on the stack. And if we want to read that number, we have to type the dot again. See, now it says 7. If we want to do that all on one line, it's like this. 2, 5 plus dot. Perfect. And it should come back with the number 7. Perfect. So let's see how that looks visually if we want to. Let's assume that the red power ribbon cable, this stuff, represents the number 2, and the bundled cable represents the number 5. Okay, when I typed 2, 5 plus, what it did is it put number 2 on the top of the stack. Then it said, oh, I've got a new number that has to go on the stack. It takes number 2 off the top, puts it down one level, and then puts the number 5 on the top of the stack. Okay, so now 2 is the second position on the stack, and 5 is the first position. And a stack will always function in the form of last in, first out. Yes. And so what that means is the last item to be put on the stack is the first item taken off the stack. So if we wanted to, okay, we could do the following. When it did the addition, it takes them both off the stack. So there goes the 5, and there goes the 2, and then it puts the number 7 on the stack. Let's represent that with a torch. Okay, so that's how it worked. And then when I did the dot, it took the 7 off the stack and put it out on the screen. Now let's demonstrate how we could use this stack-based language for a couple different functions. Let's do the 2 and the 5 again, and I'm going to demonstrate this with the numbers, let's say 2 and 4. That'll be a little bit easier, and I'll show you why. Okay, so let's say we wanted to put 2 and then 4 on the stack. What it would do is, say the ribbon cable is 2, it puts it on the top, and then it takes 2 and it bumps it down 1 and puts 4 on the top. Okay, so let's demonstrate that now by just going to our computer and typing 2 and then 4. Okay, 2, 4. All right, so right now the stack has 2 and 4 on it. Okay, now if I did a dot, which number would come off? 4. Let's see what happens. Okay, 4 came off the stack. And what it did is it took this symbol off, took the ribbon cable off, and then put the ribbon cable back on the top of the stack. So now 2 is the one on the top of the stack. Okay, and we'll go over here and type a dot again. 2 is the number on the top of the stack. What that did is it pulled the 2 off, displayed it on the screen, and now the stack is empty. So if we do another dot, it's empty. All right, so those are the things you need to know to get started with how I'm going to be doing this, okay? So let's create a word that's going to take advantage of this. So there's a couple other nuances to this, and a couple of them that I'm not super perfect about, but I'm going to kind of explain it, and hopefully it'll make sense. All right, now there's a couple other words I'm going to be using, and those are dupe and swap. All right, let's show you dupe first. Let's just put the number 2 on the stack. 2. Okay. 2 is on the stack. Let's represent it up here with a ribbon cable. Okay. Now if I were to type the word dupe and hit enter, you can see that it just ran. What that did is it duplicated the top thing on the stack and bumped it down 1 and put another one on top. So now we have on the stack 2 and 2. Okay, so just duplicated it. That's what duplicate does. Okay, now if I execute the dot command, it pulled the number 2 off the stack, this one, and of course it's going to bump this 2 back up top of the stack. Okay, so if I put another dot, the number 2 is there again. It's pulled this off the stack, and now the stack is empty. Dot again, empty stack. Cool. Swap will swap the top 2 positions on the stack with each other. So let's put 2, 4, and just leave that like so. So now we've got 2 and 4 on the stack. So what that did is it put the 2 in, okay, and then it bumped the 2 down 1 and put the 4 in. Cool. So 4 is on the top, 2 is on the bottom, and if I executed a dot right now, it would output 4, right? Just like it did up here. 2, 4. When I execute the dot, it gave me a 4, and then the next dot gave me a 2, and then it was empty. If I issue the swap command, what that's going to do is it's going to swap the positions. Okay, so what that's going to mean is we're going to have this guy on the bottom and the ribbon cable on the top. Or in other words, we now have swapped the positions so that 2 is on the top and 4 is on the bottom. So before we had 2, 4, we outputted 4 and then 2. This time when I do a dot, I should get a 2 first, and the next dot should give me a 4, and the next dot will give me an empty stack. Okay, So hopefully you guys have been able to follow along with that so far. If not, don't worry too much about it. You're not going to have to know how this works in order to play with this computer when you get my world download, but I'm just trying to kind of explain stack-based languages to you, and hopefully it'll help you to follow along with some of the programming I'm about to do. Alright, so now that we've learned all these nifty little tricks and how to deal with a stack and the words on it, you can see I've already created some words here, and I'm just going to clear them off by forgetting the word test, because I don't need anything beyond that. And now if I type words again, you can see that the only things that I've got are all off and all on. And what I'm going to do is, maybe I'll forget those as well so you can see how they work. Did I show those last episode? Yeah, I did, so we're cool. I showed you all off and all on. I just adjusted the loop that I did. Instead of going from 10 to 20, I went from 10 to 40. So it includes, you know, the 20 to 30 and the 30 to 40 block. All right, so now let's define the blue side. Okay, now what we've got here are IOX addresses from the number 10 all the way down to the number 19. So what I want to do is pretty much create a program such that I can define a color that gets emitted on any one of these thingies and define what color it's going to be by their position. So let's start counting a little bit. We could call this position 1, 1, and this one 1, 2, and this one 1, 3, and 1, 4, and 1, 5, and 1, 6, and this can be 2, 1. And 2, 2, and 2, 3, and 2, 4, etc. Okay, all the way down to the bottom right corner would be 10, 10. And this up here would be 1, 10. And this down here would be 10, 1. Okay, hope you're following along with that. And maybe I'll put some, you know, markers on here to make you guys be able to figure out which, you know, system is what. But the top left basically should be 1, 1. So to activate the blue laser on 1, 1, we want to initiate a command which will open up IOX address number 10 and emit a signal on the white wire. And that should turn on this blue line and connect over to here. Let's do that manually right now. And by doing that, we want to do 10 IOX address, exclamation, and that activates the IOX address number 10, the top right guy. And then we want to do 1 IOX set, and that's the white wire. And ta-da, we've got a blue laser on the top left. Okay. Now if we wanted to get the next one down, we'd want to do 11 IOX address. Okay, and then we want to do 1 IOX set. Ta-da, the next blue line went on. Cool. Now if we want to go over to the right, we need to go up in binary numbers, remember. So the next one to the right will be the number 2. 2 IOX set. And it goes on. But not 3 is next, 4 is next. What is that? 4 IOX set. Okay, that turns it on. And then we want to go 8. Remember when I did my frame query, I had, you know, all the different colors represented by their binary representation. So 1, 2, 4, 8, 16, 32, 64, 128, 256, and 512. All right, so I would like to write a program such that I can just type in the number of the position, so 1, 1, and then the color that I want it to be. I think that would be cool. How am I going to do that? Well, let's get started. All right, so first off, I have to get it set up so that this number 1 here can figure out the IO address to go to. Okay, and that's pretty easy. It's simply an addition by 9. So 1 plus 9 is 10. Row 2 plus 9 is 11. Row 3 plus 9 is 12. Okay, now you might be seeing why I changed the layout of this. Okay, and row 10 plus 9 is 19. So all I have to do to translate from the row number to the address number is add 9. Pretty simple. All right, now I'm just working with blue so far. We'll get to red and green in a minute. All right, so to do that, all we have to do is say 1, okay, 9 plus 1 plus 9 is 10. So I have to write a command that'll represent that the number 10 is the one, the top right guy, to activate whenever the first number that I give it is 1. So let's say we wanted to do the following. We'll call it define a word row 1. And this is just demonstrating for you guys. Or we'll call it just row. Okay. Sure. And what I'll make it is 9 plus IOX address exclamation. And what that's going to do is it's going to take whatever's on the stack currently and semicolon to close it, and it's going to add 9 to it and then issue the IOX address command. So if I type in the number 1, for example, and type row, it should change the IO address to 1. Okay, so let's turn everything off. Everything's off. And we'll do a to IOX set. Notice that it didn't work. What did I do wrong? Alright, I didn't do anything wrong. Maybe there was something on the stack already. I messed something up. But anyway, it works. It did work the way I explained it, so everything's good. Anyway, let's do 1 row. And that should set the row to the top line for blue only now. And we'll do 2 IOX set, and that should turn on that one. And if we do 8 IOX set, it should turn on that one. Okay, if I do 4 row and 1 IOX set, it should turn on the 4th row. Okay, so that's how we're going to translate from the row number to which of the blue colors we want to activate with the IO expanders. Now let's talk about how we're going to figure out how to translate the column number, which is going to go from left to right, into its binary representation. And that's a command that I don't fully understand. It's a left shift, and it basically works like this. If you want to take a number and get its binary representation, you type the following command. Let's say we want to get the binary representation of 5, which is actually 32. Okay, 5, 1, swap, double that thingy, and I think that will do it. And that should output 32. Ta-da! Okay, that's a binary left shift. Don't fully understand what that means, but if you're good at binary and you're really good at this whole programming thing, you'll understand it. If you want to read more, just look up fourth and then left shift, and there'll be a top tier, Google search will figure that out for you. If we want to do 4, we can do 1, swap, and this should come back with 16. Okay? Now there's one thing you want to remember, is in binary you start counting from 0. Okay? So if I want to do row 1, okay, that guy right there, what command do I want to issue? Well, I want to issue the command of 1 IOX set, right? So if I do 1, 1, swap, and do that, what am I going to get? Dun, 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 the suspense is killing me. 2, oh, that's a problem. So I want to start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, rather than 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It will be easier for me to count from 1 to 10, and probably easier for you guys to use it as well, rather than counting 0 to 9, which would be a little bit easier. So all I need to do really is create a command that'll do the following. So let's say we want to create a command called column, and we'll call it like this. First off, it'll take whatever's on the stack and subtract 1. This 1 minus is a special command. Another way to do this would be 1 space minus, and that would subtract 1 from whatever's on the stack. But if you just do 1 minus, it does the same thing. It's like its own function where it subtracts 1 from whatever's there. Okay, so if I give it the number 1, it's going to subtract 1 and make it 0, and then the power of 2 of that is 1, so we'll get what we want. Okay, and then we want to do IOX set on that command, and then a semicolon to define the word column. So what this should do is, if I give it like the number 5, for example, it'll translate that number 5 to 4 by subtracting 1. It'll come up with number 16, and then it should output that IOX. So let's try it. I'm going to go all off again. Okay, everything's off. I'm going to set the row to 1, and I'll set column 1. And that should turn on column 1. And if I set column 4, that'll turn on the 4th column. 1, 2, 3, 4. And if I do 5 column, see how that works? Okay, so far we're getting somewhere. All right, next let's combine these into 2 commands into one function, and we're going to call it the function blue. Okay, because we really right now are only controlling the blue laser, and we're going to want to expand that further. All right, so let's do this. Now this is where the whole stack-based thing and why I explained stacks is going to come into play. But let's define the word blue. Okay, I want to give it two numbers, and I want the first number that I give it to be the row, and the second number to be the column. And let's see if I do this right. I might have to swap it because I'm forgetting exactly which way I want to do it, but we'll figure it out. Anyway, so the first thing I would need to do is set the I/O address of what I'm doing. In order to do that, I need to do the 9 plus thing again, remember? So let's do 9 plus IOX address exclamation, okay? So let's imagine that I gave it, 1, 1, okay? The first one that I gave it is getting added 9, so it's going to go to the number 10, okay? The number 10. And it's going to set the IO address to that. Now remember, the next one is still on the stack, so the next command we type is going to be executed on the next thing on the stack. And that's where we want to do this whole swap thing to get the binary representation. So in order to do that, we combine it with the 1 minus 1 swap this IOX set semicolon. And what this should do is allow me to pass two numbers, the row and the column, to the command blue, and it should turn on the blue laser on that row and column. Let's see if what I did works properly as soon as this word is done being written. Okay, so here we go, big machine. Let's try row 1, column 4, blue. And like I said, I might have swapped these. Yeah, I did. So we went with row 4, column 1. All right, so what we want to do to fix that, okay, forget blue. All right, I want to define blue again. First thing we want to do is swap the things on the stack. Then we do 9 plus IOX address exclamation 1 minus 1 swap IOX set semicolon. Let's see if this works this time. So it's going to swap it. And I just think it makes more sense to choose the row first and then the column. Or yeah, you know what I mean. So 1 for blue should turn on up there. Ta-da! Row 1, column 4. Okay, all off, everything's off. Okay, 1 for blue. 2 for blue. Sweet. 3, 7 blue. Haha. 4, 10 blue. Everything working? So far so good. 5, 1 blue. Oh yeah, what's up? How's it going? So we've now written a little program that I can pass the numbers that I want, row and column, and it'll set the blue laser on that. Now let's say we want to do the same for green, okay? In order to do that, we need to do pretty much the same thing, swap, but instead of adding 9, remember, the green lasers over here are numbers 20 through 29. So instead of adding the number 9 to it, we want to add 10 more than that, so we want to do 19 plus IOX address, exclamation, swap, IOX set. Because the colors of the wires, the white, orange, and all those colors of the wires, they're still the same. So we don't have to change this part of the function over here. We only have to change the part of what's being added to 19 instead of 9 to get the green lasers to activate. So basically 10 more. Okay, so now if I do 5, 1, green, our green laser should turn on at row 5, position 1, column 1. Perfect. Look at that. Okay. And if I did 1, 1, green, sweet. Now we're getting somewhere. Cool. Now let's say we wanted to do red. Pretty simple and straightforward, right? 29 plus IOX address, exclamation, 1 minus 1 swap. I really hope you guys are following along, because if you're not, you're probably saying, huh, what? And this might be a little bit boring for you. But hopefully the results of this are entertaining. So now I've just defined the word red, which will control the red laser in exactly the same way. Because, basically we're in a good position here. So let's turn on that one. Row 2, column 2, let's say. So all I should have to do is 2, 2 red, and we should get that. And 2, 1 red should get the one on the left there. And if I want to do 5, 1 red, that should turn that guy on and make it a white light. Perfect. And all off again to turn everything off. I'm liking this already. Alright, so now let's try something real quick. Let's use 1 and 1. I'm going to turn on red and green. Okay, now let's say I wanted to get it back to red again. Okay, so we've got red and green on, which is making yellow. What if I want to get it back to red? Well, we've got a problem. It's no easy way for me with words yet to turn off a color. So let's set that up now. This should be pretty easy. Anybody want to guess on how it's going to work? It should be the exact same commands, except we want to do an IOX reset instead of an IOX set. So let's do this. You ready? Colon red off 29 plus IOX address. So now we're setting the IOX address to the right one. And instead of turning on the laser, we turn off the laser with the IOX reset command. Okay, and what that should do is turn off the red laser, which will make it just green. So you ready for this? Let's give it a shot. Patience is a virtue, as it's writing that to memory. 1, 1, red off. Green laser. Perfect. And I'm going to code in green and blue off right now. And real quick, I want to jump back in. I just forgot the word blue by design, and it erases all the words I defined beyond it. So we've still got row and column here. I want to change it to blue on. So let's call it blue on and do that again, where we did a swap 9 plus IOX address, exclamation 1 minus 1 swap. And I'm just changing the word to blue on instead of blue, and you'll see why I do that in just a moment. But I'm going to redefine blue on all the way through red on, green on, blue off, red off, green off. Alright, taking a brief break from what I was just doing, just to point you guys to the fact that I'm making a back pane. There we go. One of those should be enough. And then I need a RAM module, which I believe requires a diamond. Where are you at? 8K RAM. And 4 of these red doped wafers, which I have some of. I just need to grab a diamond. Any in here? Hey, perfect, 1. Ha, nice. So there we go, 8K RAM module, because I want to write all these onto a disk so that if I ever have to, reload everything, I can just load it off the disk rather than having to retype everything. So the disk is already in the drive. I think I should probably, did I spit the disk out or what I do here? 4th boot disk. There it is, blank floppy. All right, let's halt the computer. That one might be the one that forgets all the words. I guess we'll find out. We'll get our back pane on here. No, wait, that's okay. This guy's the back pane. 8K RAM module. Let's move the floppy drive while we're at it. Should probably go over here. Floppy drive goes there. And then we just need to bring the ribbon cable up here. Beautiful. And then we should be able to start the computer. Alright, things are there. I don't know why it didn't start though. Reset. Start. There we go. 8K RAM free. And words probably got reset. No, they're still all there. Perfect. Alright, so now I'm going to start doing with the floppy thing, blank floppy. And we'll name this disk. Alright, just did a bunch of typing, and I'm going to flush what I just did to disk and do a 1 list, and we should see all the stuff that we just did there. So that creates a bunch of words for us. So now if I type the words command, notice that I just have column, row, all off, and all on. And if I do a 1 load at the moment, it should load all those words into the computer for me. And that's going to take a moment or two, so I'll be back when it's done. There we go. Now I can type words and see red off, green off, blue off, red on, green on, blue on. Beautiful. And everything should be off at the moment. Now let's do all off. Get all the lights off. And now I should be able to do 5, 3, blue on. There we go. 5, 3. And we could do 6, 4, red on. And we can probably do 4, 2, green on. And then I could do 4, 2, green, off. 6, 4, red, off. And I'm just testing my commands there. It would help if I spelled red off correctly. There we go. And 5, 3, blue, off. Now, you ready for the best part? I'm going to get it ready. Now, you might have been wondering why I decided to change it from blue to blue on. Well, we're turning on the blue laser, but we're not necessarily making that pixel blue. Why are we doing that? Well, let's imagine green was on already. By typing the blue command, it doesn't set that pixel to blue, it just turns on the blue laser. So now let's set our commands to set it to actually be blue, and this is how we're going to do it. We're going to have to use a new command that's pretty similar to one that we did before, so don't worry too much about it. But basically, how do we get it to turn blue? Well, we might not know whether green or red are on already, so just to be safe, we'll turn on blue and we'll turn off green and red all in the same command. How are we going to do that when we only have a stack with 2 numbers on them? Well, let's check it out. So we'll do 0pp just to start creating a new word. We'll call it blue. Okay. And what we'll do is, first off, we're going to pass it those 2 numbers, right? And when we use them in our first command to maybe turn on the blue laser, they're going to be off the stack. So we need to duplicate them, right? Well, we know how to duplicate the top number on the stack, so let me show you a new command called toDup that duplicates the top 2 numbers on the stack. So if I pass it 1, 4, it's going to duplicate those 2 numbers, and it's going to have it be 1, 4, 1, 4. And I want to do that again because I want to do 3 times I need to use these numbers. So now it's going to be 1, 4, 1, 4, 1, 4. Okay? Makes sense, I hope. And then what we can do is called blue on, red off, green off, semicolon. And that should work. And let's test it by doing a load of 2. And that should load that new command into memory. Oh, well, I'm sorry. To load. Okay. And 2 might still be on the stack now, but I'll fix that in a second. All right, there we go. Everything's cool. We've got a new word called blue. So let's give that a shot. So if I were to do 5, 4, blue, it should make that blue. Now if I do 5, 4, green on, and 5, 4, red on, it'll be white, right? There we go. Now if I do 5, 4, blue, it should all in one command turn off everything but blue. Beautiful. Now let's forget blue, because I'm about to reload it, and do a 2 list. We should just see the blue command there. Now I'm going to define words for green and red. All right, there we go. I've defined words for green and red. Okay, I haven't written them to memory yet, but you know, I'll do a flush just to make sure the disk gets written, and do a to list. And I need to do a to load to get these all in here. But you can see that the blue command will turn on blue, turn off red, and turn off green. And the green command turns off blue, turns off red, and turns on green. So green's the only laser on. And red will turn off blue, turn red on, and turn green off. Well, heck, while we're at it, why don't we create a new command, number line 3, called yellow. And how are we going to do that? Pretty simple. This is why I'm doing it this way. Okay, yellow is a combination of green and red, right? So if I do blue off, red on, green on, semicolon, we should be good to go, right? I would think so. Except I forgot the PP there. That's okay. I'll fix that in a second. Oh well, I wrote yellow to memory anyway, so let's just test it. So all I got to do to test the yellow command, let's try turning on 2, 3, yellow. And this should work. Hey look, it worked. Beautiful. All off please, and forget yellow. And now I have to get it onto that to list. So I'm going to go create yellow. It's technically magenta, I think, but I'm going to call it purple just to make it easy. Cyan and white. Alright, so now we've got definitions for yellow, which is basically blue is off, red is on and green is on. Purple, which is blue and red on with green off. Cyan, which is blue and green on with red off. And white, which has all 3 on. So let's do a to load, and I'll come back when it's finished doing its load. Alright, it looks like it loaded up all my words. Let's check it out. White, cyan, purple, yellow, red, green, blue, and then all the offs and ons. And then, of course, column and row, which was really just an example earlier, and all off and all on. So let's see. Everything's off still. Let's try 5 for white. Should make it white there. Right? Row 5, column 4. Beautiful. And let's do 5, 3, blue. Cool. 5, 6, cyan. Sweet. 5, 5, yellow. I'm just testing out all the colors. 5, 2, red. Type it again. Remember, caps counts. Should turn on there. There we go. Sweet. 5, 1, purple. Beautiful. I like it. And what color am I missing here? Green, yes. 5, 7, green. There we go. We've got all 7 colors that are possible. Sweet. Okay, there's one more set of words I'd like to command. Let's see. I did do a flush before, didn't I? Let's just do it anyway, just to make sure. We'll do a to list. Make sure everything's good there. So there's all my individual colors. I'd like to get a list of commands to set the entire color of my screen, like that. And that's a pretty easy one, as you can see right here where I defined all blue. So let's forget all blue, and just define it as 3 list. Should be empty list. Looks good. So I'm going to define it 0 as 2010. No, wait, I have to do colon. All blue, 2010 do IOX address, exclamation 1023 IOX exclamation loop. Now what this is doing is, let me walk you through it. All right, the number 20 and the 10 are part of a for loop, and this says count up to number 20, but start at 10, and do the following command each time you loop through. Then the letter I here is a built-in variable that tells you the current position in the counter, and it sets the IOX address to the letter I. It's a variable. And it executes the IOX command, writes it, and then does 1023 IOX, which turns on all the colors that we are using at the moment. And then it loops through. So it starts at 10, and it does 10 IOX address, 1023 IOX. And then it loops through again. It goes to 11. 11 IOX address, so it's on 10, 11, 12, 13, 14, 15, all the way up until 20, and then when it hits 20, it stops. Okay, so that's how it works. So I'm going to do another one, pp, all, let's call it red, and let's go with green first, and this should be 3020 do IOX address, exclamation, 1023 IOX, exclamation, loop, semi. And maybe I want to change this to all green on. I want to probably do it similar to the way I did it last time. So we'll do like all green on. And we'll call it 3010, 3020. Yeah, I probably want to do this the same way I did it last time. Do IOX address, exclamation, 1023. Cool. Alright, I'll be back in a minute. Alright, there we go. I just set commands all blue on, all green on, all red on, all blue off, all red off, all green off. And you can see that it basically will set 1023 IOX, which, turns on all the cabling, and then 0 IOX turns off all the cabling. So there you go. And I'm going to do a flush and a 3 load, and that's going to take a minute or two, so I'll be back. And just in case you guys were curious while this was loading, the all off command does a loop of 10 through 40. So it's just a straight loop, 10 through 40, 0 IOX. And all on does a 10 through 40, 1023 IOX. But it looks like everything's good, so let's do all off. Okay. There we go. And now if we do all green on, ta-da! What happened here? Interesting. I don't think I've ever actually tested that part. I might need to bump these lasers up a little bit. Looks like they're falling a little bit short. I didn't think that would be the case, but I guess they do. So some of them might need to be a +20 green laser. See? This is why we test things. Red's cool. Red doesn't have any problems. Wonder if blue has any issues. I didn't think it would. Yep, blue's fine. Huh, green. Interesting. Maybe because, I mean, we're 2 blocks from here, where this guy's only 1 block away. Interesting. Oh well, I'm gonna have to replace some green lasers, aren't I? I am. I'll be back. Alright, the last few of these guys are going in. That's 20. This is 10 to 20. 10 to 20. And hopefully, if I did everything right here, I should be able to do all green on and get, nice, a full board. Sweet. Now I'm going to, of course, define the all green, blue, red, yellow, purple, cyan, and white colors with the number 4 list. Should be blank. Good it is. And I'll be back in a minute. And here are the commands for all blue, green, red, yellow, cyan, purple, and white. Should make sense. And another 4 load should get us going, and I'll be back in a few minutes. And it looks like we're in business. I can now type all white, all yellow, all green, whatever I want. So let's do like all blue and make, let's say 3, 3, 3, 4, 4, 3, and 4, 4. Yellow. That should work pretty well. Just had to finish typing it. Sweet. And then let's do, I guess that's 5, 6, 7, and 8. Cool. There it goes. Not too shabby. Hey, what'd I miss? I missed 3, 8. Did I just mistype that? Yeah, I did. Derp. Better. Alright. Let's go with 7, 3. Now, of course, I could have this all be one command, and it would be faster, too, if I had it all within one word, of course. But let's see if I do this right. What do you think that should be? Alright, so like I said, once you get what you want going into a word, it should be a little quicker. Let's type smile, which I just programmed in here manually, and we should see a smile show up. Ta-da! Sweet. That is cool. All blue, good to go. All purple, and smile. So like I said, rather versatile. I'm not done with this. Nope, not by a long shot. The basic build is done, but now we could really use this for all kinds of fun and interesting purposes. those of you who are like really into the whole programming thing could probably come up with things way better than me, but I do have something particular in mind. Unfortunately, this video has run way longer than the 30-minute mark, so I do need to wrap up here, way past my normal wrapping up point, but I am really happy with the way this build turned out. It looks cool, and it just looks clean, I think, is one of the things I like about it. It looks cool, and it functions pretty well. And the programs in the computer should all work pretty well. All the programs are written on this disk, so if the computer ever freezes or crashes or loses its memory or something crazy happens to it, I should be able to, let's make sure we do a flush on here real quick too, just to make sure everything's written. For list, all my commands are there. Sweet. And to list, all my commands should also be there. And everything should be good. So anyway, this is Direwolf20 signing off on episode 83 of Direwolf20's Let's Play. I know a lot of it was in the computer, and I'm hoping this episode was still pretty entertaining for you guys. Feel free to leave comments and let me know if you find that it was, you know, maybe kind of boring or you didn't like so much computer use. Like, it was pretty much an entire episode of programming a computer. I understand that. But hopefully you learned something about Forth. Hopefully you enjoyed seeing this whole thing come together. And I'll catch you guys next time in 84, where I might want to do a few more things with this and then move on to yet another new build. All right, guys, take it easy.